Today's lesson looks at the properties of logarithms, so it should be a little review from our IM3 days. We're looking at expanding and condensing logarithms. So expanding takes our values here, makes them bigger, writes them as multiple logs, while condensing makes our terms smaller, condenses it down into one log. And there's a couple properties that we can use here. All right. So the first one, go ahead and write it out. A to the power of log base A of m. Now remember, when we raised something to the same base power, so see A is here and A is the base, that A and that log cancel each other out. So all we're left with here is m, or that value right there. Another one, if we took log base A, and then we have an A here to the R, again, this log and this A cancel each other out, and the only thing that's left would be the letter R. A lot of the ones we're going to be seeing are these multiplication, division, these types of setups. So remember, multiplication and addition go together. And we'll see how that looks again. So if I've got something that says log A of mn, all right, so this is multiplication here. Okay, this is the multiplication side, m times n. M times n. This is equal to, multiplication and addition are the same thing, so we can expand this into two logs, log base A and log base A. Both have the same base, and multiplication goes with addition. This one's going to have the m, this one's going to have the n, so we're just splitting the m and n apart into addition. The same thing is going to apply for division. Division and subtraction go together. So if I have a log base A of m over n, so this time the two m and m's are connected by division, so that means it's going to come out to a subtraction problem now. Still two terms, so log base A, m, the top one comes first, minus log base A of n. This time it's a subtraction problem. We also have product of a power. I've referred to this in the past as the traveling exponent. So if I have log base A of m to the r power, that exponent is allowed to travel to the front of the log, and it would really look like this, r times the log base A of m. Okay, see how that r exponent traveled to the front? So let's apply these to some examples. And the first couple ones we'll do will be expanding problems. So let's go ahead and expand, aka make bigger. So the first one is log base 3 u to the 3 over v to the 4. So a couple things going on here. First thing I see is division. And remember, division becomes subtraction. Subtraction. And it's made of two pieces. I've got the piece on the top and the piece on the bottom. So there's multiple ways you can do this. I'm going to go ahead and write those out now. So it's made of two pieces. So the top is u to the 3. The bottom is v to the 4, because you see division becomes subtraction, that subtraction symbol. And we can expand a little bit more, because if we look at this piece now just on the u, it has an exponent 3, and the exponents are allowed to travel. Same thing on the 4. But this only moves as far as the log it's connected to. So in the end, we have 3 log base 3 of u minus 4 log base 3 of v. And there's our final answer for that. We've expanded it as far as we can. All right, so let's try another one. So again, another expand problem. Let's take the log base 7 of a, b to the 5, whole thing to the 5. All right. So again, I'm going to expand this out. Usually look at the variables in here. Okay, they give you a hint. So I've got an a and a b inside, and they're connected by multiplication. So I have a multiplication, which is going to come or become addition. But I can't really break those apart because they have the parentheses with the exponent 5. Now, you could be tempted to move that 5 into the front right now, but that 5 is actually just connected to the a and the b. And thinking back to our PEMDAS rules here, this actually just comes out to, and we actually don't need the parentheses anymore. I'm trying to erase that. So we've got a to the 5 and b to the 25 after we multiply, and it's still log base 7. And remember, this multiplication that's here, that's going to get split into addition, and it's going to be 2 log values, so log base 7 plus log base 7. This one's going to get the a, but we can kind of save ourselves a little bit of time. You see that exponent's also going to move to the front, so it'll be 5 log 7 of a. This one's going to get the b, but the 25 is going to move in front of this log, so 25 log base 7 of b. Alright, so if you have to do it in multiple steps, that's fine. If you want to just do it kind of all in your head and put it all together, that's fine as well. Alright, let's see one more expanding one. Let's take log base 7 cube root of a times b times c. Okay. Now when we see the square roots and the cube roots, that's got this symbol here with the cube root. Now we don't really know how to operate with that, but we do know how to operate with exponents. And if we think back, square root is the same as exponent 1/2. Remember that. But if it's cube root, remember that's exponent 1/3. So we can rewrite this as exponents. It's actually a times b times c, and all of these are to the 1/3 power. Okay, because cube root is the same thing as 1/3. Or if you want to put that 1/3 on everything, a to the 1/3, b to the 1/3, c to the 1/3, still log base 7. So this time it's made up of 3 pieces. We have the a, the b, and the c. So we're going to expand this into 3 logs. One with a, and remember, multiplication becomes addition, so log base 7b plus log base 7c, and in front of all those gets their exponent, 1/3, right? Each of them get their own 1/3. Okay, and that's, remember, the exponent that traveled. So there we go, we have our expanded out logarithm. Alright, so let's take a look at a couple condense problems. So we're going to go ahead and condense these down. So in order to condense, they'll give us multiple logs. We need to condense it down into 1 log term. There can only be 1 log in the end. So we've got 5 log base 7 w plus log base 7 u over 3. So we kind of think back to the things we just did and reapply them backwards. All right, so up front here, or however you want to look at it, that's addition, and if we have addition, that's going to condense it back down into multiplication. So eventually we're going to have multiplication. This exponent, or this 5 in front, travels backwards, becomes the exponent on the w. Now the only tricky part here is the 3 divided by. If you want, you can rewrite this, because dividing by 3, isn't that just the same as multiplying by 1/3? And now that 1/3 can travel and become the exponent here. And I'll rewrite this front part. The 5 is going to travel and become the exponent here. So we're going to condense this down. It's going to be 1 log, or we'll go multiple steps. So we'll move the 5 here as the exponent, plus log base 7 to the u, 1/3 is the exponent. And remember, this addition is going to become multiplication. So we'll write 1 log with that base 7. It's going to be this piece times this piece. So u to the 5, or w to the 5, u to the 1/3. All right, and if you really want to clean this up, remember we know that 1/3 power is the same thing as a cube root, so we can rewrite this back as a cube root u being multiplied still together. All right, and looks like one last one for today. We're going to go ahead and condense log base 2 of c plus log base 2a over 2 minus log base 2 b minus 1 over 2. Okay, so it looks like 3 unique pieces here. The first 2 are connected with addition, the other 2 are connected with subtraction. All right, so this one's going to become a multiply, this one's going to become a divide. Anytime you see those fractions, it might be a good idea to rewrite them as, you know, a little small fraction in the front, so the 2 becomes a 1/2 right there. Maybe at least then we can make a little bit more sense of it. All right, so let's see. On the first one, there is no exponent to travel. This one does have an exponent to travel there. This exponent will travel here. Don't carry the negative with it. Remember, the negative means divide. So, in the end, you want to carry these things from left to right. That's usually a good idea. So we're going to condense this down into one log term. So it's log base 2. You notice they all have the 2. Let's work from left to right. So it's c times a to the 1/2. So c times a to the 1/2 divided by, see this divided by, and on the bottom is going to be the b minus 1 with the whole things to the 1/2 power. And that's technically a correct answer, but we're going to go ahead and flip these back. Instead of exponents with fractions, we're going to flip them back to our radicals. So it's really c times square root of a. Remember, 1/2 is the same as square root. And then on bottom, square root of b minus 1. All right, so that's my one single log term there.